My name is Peter Hubbard. I'm part of the instructor-led training department at MongoDB, senior technical curriculum there. And I'm going to be taking you through a live upgrade from MongoDB version 7 to MongoDB version 8. Now, I'm going to do this using an installation which I have already prepared on MongoDB Atlas. There I have a staging environment which is already on MongoDB version 8 and a production environment which is still on version 7. Now, because the upgrade process takes around 10 minutes and it's not exactly a spectator sport, I will kick off the upgrade, and while that's happening, I'll talk about the various upgrade considerations you should take into account. We'll take into account, for example, backups and compatibility. We'll talk about the upgrade process itself. We'll see how to monitor the upgrading systems, and then we'll talk about best practices for a long-term upgrade strategy. Now, first of all, let's look at the MongoDB Atlas setup that I will be using. Quick recap, first of all, MongoDB Atlas is our database as a service offering. Fully managed MongoDB instances running on machines hosted by major cloud providers. Now, this includes a baseline level of security, including private network access and automatic operating system updates. We have a full suite of monitoring and reporting tools, including real-time dashboards, slow query monitoring, alerts with third-party monitoring services integration, deployment metrics logging, and auditing. We also have support for native cloud backups, online archiving, point-in-time backups, and restores. And all of this can be controlled using the web-based user interface, or programmatically using the API, or even by using a command line interface. And I'm going to be using a mix of these today. Now, what I have already configured are my staging and production environments. They are both identically configured 3-node replica sets. I have already taken a snapshot backup from my production cluster and restored it to my staging cluster. And I've already upgraded my staging cluster to MongoDB version 8 and confirmed that everything is working, that my upgrade is not going to affect my data. So I already have a high level of confidence that the upgrade on my production server will be a success. I am managing my configuration using Terraform, which allows me to define my configuration as a text file and use automation to plan and deploy my changes. And let me show you that now. So in my configuration file, you can see that I have parameters for the various variables over here, and then for my production cluster over here. You can see that I have a replica set of the tier M10 with 3 nodes running on AWS in the EU West 1 region. These two settings over here show that I have continuous cloud backups enabled, and in the advanced configuration, you can see that I have disabled JavaScript support. My transport layer security is set at a minimum level of 1.2, and no table scan false means that I can run queries which require a full collection scan. And just at the top here, you can see my production cluster major version over here. This is just a variable which I can set. You can also see my staging clusters configuration here, and you can see that the major version of my staging cluster is also a variable. It's just a variable, so I'm checking it. This means if I go to my variables file here, I can change the MongoDB version number for my production cluster from 8 to 7. And this is the only change that I need to make. You can see that Terraform is going to perform an in-place update. And what it is going to do is it is going to update my major MongoDB version from 7.0 to 8.0. What I'm also going to do is I'm going to pin the FTP, and I'll talk about what that means in a second. So now that I've planned this change and I'm happy with it, all I would need to do is apply the plan and the upgrade would start. However, there are a few things that I just want to check before I do so. Now, there will be some things that I need to check regardless of whether I'm using MongoDB Atlas or MongoDB self-hosted, and there will be some things which are going to be specific to how I have deployed MongoDB. For instance, in a self-hosted deployment, I need to check whether my operating system is supported. Supported operating system versions are those which go end of life after MongoDB goes end of life. So we never have a situation where the MDB version is supported, but the operating system version is not. Secondly, I need to make sure that my CPU and architecture is supported as well. MongoDB needs AVX support under the x86-64 CPUs or ARM 8.4a or higher for ARM64 CPUs. Mostly, if your current version of MDB is running on your hardware, then the newer version will work as well, but it is worthwhile to check this out. Regardless of whether I'm running Atlas or using a self-hosted environment, I need to make sure that my application servers are using the latest language driver as well. It's best practice, of course, to keep the language drivers up to date, but it's especially important when upgrading the server, as only updated drivers are going to be able to make use of the new features of a new MongoDB version. So assuming that I've done all of that work and I'm ready to upgrade, here is my pre-upgrade checklist. Now, first of all, I need to check that the cluster is in a healthy state. I'll use the command line interface to check that. We want to see that both clusters are in idle state, and that's what we want. I'm also going to check that I'm not currently taking a snapshot or making a backup. Here I should see that my scheduled backup is in a completed state. And then I will ensure that I am not currently in an Atlas maintenance window. Now, I can schedule these maintenance windows as I like. Atlas will use these windows to perform critical updates to the underlying operating system or to install new patch versions of MongoDB. And then lastly, I'm going to make sure that I am pinning the FCV, and let's have a look at what that means. FCV stands for Feature Compatibility Version. Essentially, I'm saying that if there are any backward incompatible features in the new version, I want to disable them during my burn-in period. Now, a backwards incompatible feature would be a feature which changes the format of the data stored on disk. If I wanted to downgrade my MongoDB, then I would need to first remove any data which uses those new features. This would complicate my downgrade process. So instead, I can use the FCV to hold off on enabling those features. Now, in MongoDB version 8, there is actually only one feature which will affect the storage format like this, just so you know, but we're going to pin the FCV anyway as a best practice. Note that in Atlas, you must specify a date for the FCV to expire, and I have set that for a week from today. The maximum that Atlas will support is 4 weeks. Now it's time to kick off my upgrade. Now, just to make things interesting, I'm going to demonstrate upgrading a live system here. So a system which is actively reading and writing data. Now, while this is something that you would preferably want to avoid, remember that MongoDB is designed with resiliency in mind, and it is absolutely able to handle rolling maintenance without losing any data. I'm going to keep my client application very simple. In fact, it's just a short script in MongoSH, which is going to store a local variable, x, and increase it every loop. And then it's also going to increase a variable on the database at the same time. If this update fails for whatever reason, then our data locally and on the database is going to go out of sync, and we will see that here is going to print out an error message for me. And then lastly, every 25 iterations, it's just going to print out the local x variable value and the database x variable value, just so that I can see that everything is working correctly. It's also going to show me the amount of time that it took MongoSH to do all of this work. So do not be concerned. This is not the amount of time that MongoDB itself is actually taking to insert data. So here's my client application up and running. And you can see I'm doing this on my production server, which is still running MongoDB version 7.0.17, which is going off the top of the screen there. Now I can skip over to another tab and actually apply my change and kick off the upgrade process using Terraform. As a reminder, Terraform allows you to plan your change before you execute it. So my plan over here shows that my resource is going to be updated in place. The change is going to be simply the MongoDB major version number from 7.0 to 8.0. I am pinning the feature compatibility version to 7.0 so that I can downgrade later in an emergency. As I'm happy with my plan, I applied it, and you can see that Terraform is showing now that my upgrade is in progress. So I'm going to go over here and check the status of my clusters. And you can see that my production version is currently updating, and it's going over to version 8.04, the same as my staging cluster over there. If I switch to the Atlas user interface, you can see that the status icon for my production cluster has changed. So you can see this is now updating. I still see the old version number here, so that will change in a second. And soon I should see that this version number changes to 8.0804, and I should also see that it is pinned to version 7. While this upgrade is going through, I can just go back to my MongoSH, and I can see that my script is still running without a care in the world. And the question is, how can I run an upgrade like this without requiring any downtime? Now, remember that I've configured my MongoDB cluster to be a 3-node replica set. So I have 3 separate nodes running MongoDB, and each node has a full copy of the database, all of my data. All write commands are handled by the single primary node at the top, and the secondary nodes then replicate those write commands to keep their copies of the data in sync. As long as I have a majority of the nodes available, the database is not going to be impacted, and I can guarantee that my data is being securely audited. In a 3-node set, this means that up to 1 node can be down at any time. Once that node comes back online, it will synchronize itself with the data changes made while it was down. You can take advantage of cluster. In fact, this is what MongoDB is currently doing for me automatically. It has taken one of the secondary servers out of the replica set. It's leaving the primary and another secondary to carry the load. It's performing maintenance on this server over here, in this case, installing the new MongoDB version. Once this is done, Atlas is going to add the server back into the replica set, wait for it to catch up, and then move on to the next node. The only time we might have an interruption is when Atlas starts to work on the primary node, because then we first need to hold an election to find the new primary node. This typically completes very quickly, and MongoDB drivers are configured automatically to handle this switch over. If I go over to the monitoring on my production cluster, you can already see on the graphs over here that the cluster shard 01 over here most likely used to be a primary server. So that was initially taking the write commands from my script. This has now been handed over to cluster 02, which is now my new primary server. So this most likely means that this server has already been updated, and the update is now running on the second secondary server 00 over here, and will soon be running on shard 02 as well. Do be aware that although the cluster names are called shards, I'm not using sharding here, just using a replica set. So while my upgrade continues to run, let's quickly talk about how to use backups to ensure compatibility. Now, here's a quick review of the major compatibility changes that MongoDB version 8 brings with it. The one which affects data is the query change, whereby we no longer match a value of undefined with a query to null. We would want to test the effect of this change on our existing data, and an upgrade is a good time to do this. Of course, your development team is aware of these changes, and they have done extensive testing in their dev environments already, but here's the chance to make sure that these changes will continue to work with your production data. We can take advantage of a built-in feature of MongoDB Atlas, which allows us to restore backups to different clusters. In fact, we can take a snapshot of production data and then restore that snapshot to our staging cluster. We can upgrade staging to version 8 and then confirm there that all the compatibility changes have been dealt with. And note that you can restore your data to any cluster in any project in any organization that you manage under MongoDB. Only limitation is that if it is a sharded cluster, then the source and target clusters must have the same number of shards. Lastly, it's good to do this a bit before your actual upgrade of the production cluster so that you can get a feel for the required RTO, a recovery time objective of your backup systems. Obviously, this time is going to be heavily influenced by the amount of data you have and the level of your clusters. Now, I've shown some of the monitoring already. I just want to show you here in a static version what the timeline annotations on these metrics show. Up at the top, I can see which of the nodes is currently the primary server. So in this case, it would be shard00. I've then got two secondary servers over here, 01 and 02. The red lines on each of these graphs over here, these show when that specific node was restarted. And the yellow line over here shows when a specific node won an election to become the primary node. So what I can see here is that on shard00, it was first shut down. The upgrade took place, and then a little while later, it won the election to become the new primary server. That's what this orange line is showing. If I go over to my live event, I might be able to see if the graph updates. There it is. The yellow line, the orange line over here, just showing that shard02 most recently won the election to become the primary server. And there it is. So this is looking good. Let me just go back. Unfortunately, it looks like the environment over here died while I was working on that. So let's just see if everything is still in order. In fact, when I reconnect, I can see that I am now connecting to version 8.04. So it looks like the upgrade has actually completed. Let me check on that with the clusters list command here. And indeed, both my production and staging environments are on version 8.04, both in idle state, which is exactly what I want. So my upgrade has already completed perfectly in the background. Let's have a look at what this looks like on the clusters environment. Here's my cluster 0 production, and you can see the version number is now 8.04, and this little pin icon over here is telling me that this is pinned to the FCV version 7, and this will expire on the 13th of March. That means on the 13th of March, all compatibility options which have been disabled up until that point will be removed, and this will then become a quite normal and ordinary 8.04 cluster. So with my upgrade complete, let's have a look at the long-term upgrade strategy. Now, first we need to talk about MongoDB versioning. Now, MongoDB version numbers have the form X, Y, Z, X and Y being the release series, and then Z being the patch number. Major releases are released approximately once per year. They include a large number of new features, and the version number examples for that would be 7.0 or 8.0. Rapid releases are released approximately once per quarter. They only apply to MongoDB Atlas. They include incremental new features up until that point. Version number examples for that would be 8.1 or 8.2. MongoDB software life cycle schedule goes like this. A major version is typically going to be supported for around 3 years. Atlas is automatically going to upgrade you to a next major version if your current version has gone end of life. Now, of course, it will tell you this beforehand. In fact, it will give you at least 6 months warning before doing this, so that you can opt to switch to the legacy support policy instead. However, if you do not do this, then 6 months after your MongoDB version on Atlas has gone end of life, MongoDB Atlas will use one of the maintenance windows to automatically upgrade you to a supported version. Note also that MongoDB drivers are typically no longer compatible with MongoDB versions which are more than 3 years end of life. What does this mean for you? You need to keep MongoDB up to date. With MongoDB Atlas, you are automatically going to get updated to the latest release. So the current patch release that we have is 4.8.04. When 8.05 comes out, Atlas will automatically update you to that new version. Rapid releases, so 8.1, 8.2, you can also have those auto upgrade if you require or if you wish. A major release upgrade that requires user intervention from your side, unless, as we said, your version is already more than 3 years out of date. If you are rolling your own MongoDB installation, you have a self-hosted cluster, then the latest patch release is always going to be available through the MongoDB repository. Do note that your package manager will automatically update your MongoDB package unless it has been pinned. The way that this is done differs obviously from operating system to operating system. Each major release has its own repository, so you are never going to type apt-get updates and find yourself suddenly on MongoDB version 8. this will require you to update your repository configurations first of all. So what should your upgrade strategy be? Well, first of all, it does need to align with your enterprise's specific needs and goals. You need to track your MongoDB cluster support life cycle, monitor the MongoDB version upgrade so that you can prepare ahead of time for a well-managed upgrade process. Specifically, you should understand how does your application use MongoDB? How does it use specific features of MongoDB? This will help you identify any required application changes, which allows you to plan for these upgrades well in advance. And if there's one thing that I would like to leave you with is that you should plan for your upgrades well in advance. Don't forget to update your drivers as well. Make sure if you are a self-hosted customer that you are upgrading your platform, your operating systems as well. And use this time during the upgrade planning to do capacity planning as well so that you can accommodate future growth. And then, just in case I haven't mentioned it before, test extensively before you do your upgrade. So there it is, one live upgrade from MongoDB version 7 to version 8 without any major issues. As a recap, upgrading to MongoDB version 8 is going to improve your read-write speeds. It's going to improve your indexing, reduce sharding overheads, improve your security, and of course, much, much more. Upgrades to new major versions can be performed with minimal to even no downtime if you are brave enough. We do, however, recommend that you use tooling to automate these changes. And lastly, make sure that you plan well ahead of time for all of your, and test extensively for all of your upgrades. Make sure the process smoothly. Thanks very much for your attention, and all the best with your upcoming upgrades.
Thanks, everyone. Looking forward to your feedback when you start using MongoDB 8.0.